So last time we were seeing a few commands that are used for text processing, and one of them, or a couple of them, were for editing test files on the fly. One of the commands was tr, like translate or transliterate, or something like this, and it gets a class of characters as the first argument, and another class of characters as the second argument. And it is going to map from the first character in the first class to the first character on the second class, and so on for each character. So usually they should have the same size, or they should have the same number of characters. There should be the same number of characters in these classes. For example, if there are 3 characters on the first set, there should be 3 characters on the second set, so that the mapping will be 1-to-1. But it is also possible to have just 1 character on the second one, and then all of these characters will be mapped to just this character. And this command can also have an option -d, which means delete or remove all the characters that appear in this set. And another very useful command was sed, or streamline editor. It usually takes one file and one expression, and this expression contains some commands, some processing commands, what should be done to the content of the given file. And sed is processing the file line by line. So it takes the first line, applies the patterns that are given for processing, takes the second line of the file, applies the pattern, if it is possible to apply it, or applies the commands that are given to it, the third line, the fourth line, and so on. It can also take from standard input and process standard input instead of a file. For example, we can send some input with echo to the command sed. And here we give an expression. For example, we want to replace character A with character capital A. So this is a sed command, which means substitute or replace. And then this is the separator, which separates the command from the first part and the second part. The first part is the matching part. It is going to match this regular expression. It can be a regular expression. And then the second part is the replacement part. It is going to replace the matching part with this second part of the expression. And we can, for example, in this case, it just replaced one character and stopped the first A. If we want it to replace all the characters, then we can add this modifier G, which means global. Global means that replace all the matching patterns, not just the first one. All the matching patterns in the given line. So we are sending just one line in this case. And so since we are giving this option -G, it is going to replace all the matching parts in this line. And the sed command can have multiple expressions. For example, this is the first one, and now we are adding another one. For example, another substitute, C, with capital C. But let's use another separator, because it is possible to use different separators. Or let's use this one, for example, as a separator, this character, hash, or yeah, hash. And it is replacing the first C here as well. So it is applying this command And it is applying also this command to each line of the file. And if we add the option G, it will replace all the all the occurrences or all the matches of the expression. Now we have seen this file distros.txt. Let's change the format. So the format of the date here is month, day, year. So the month is coming first, and then the day is the second part, and the year is the last part. So let's change it to the format. We want to change it to the format year, month, day. So we want to change it to this format, and we'll try to do it with sed and using regular expressions, of course. So sed distros.txt, and okay, it is possible to add the expression after the name of the file, so we can add the expression here. Now, actually, we want to use extended regular expression. So instead of -e or -e, lowercase e, we use capital E for extended regular expressions. I will show you in a minute why it is better to use extended regular expressions in this case. So we want to substitute something, and here we will match something, and here we are going to place the replacement. So what we are going to match is we want to match a digit 0 to 9 twice. There will be 2 digits for the month, and then we match a slash, and then we match another digit 2 times, and then another slash, and then a digit 4 times. And I'm removing these empty spaces. So this regular expression is going to match a date here. But now I'm doing something interesting, because I'm using parentheses to divide this pattern into sub patterns. So I'm using parentheses to surround the month, to surround the day, and also the year. And here at the replacement, I can say /3 minus /1 minus /2. Now here on the replacement part, this /3 means the part of the line that is matched by the third parenthesis of the pattern, which means the year. It is this part, because this is the third pair of parentheses. This -1, this /1 is the first pair of parentheses, what is matched by the first sub-pattern, or by the first pair of parentheses. So here will come the month, and /2 is what is matched by the second pair of parentheses, which is the day. And let me remove these empty spaces. Extract extra characters after comma. Okay, maybe it was not. Sometimes it works, but let's put the name of the file at the end. Control E, distros.txt. Okay, it works in this case because by default it is taking this one as the first as a set expression, the first set expression. Anyway, so we see that now the date is in the format year minus month minus day. And why did I use this extended regular expressions? If I did not use extended regular expressions, then I would have to escape these parentheses with a slash, so that it can be understood as a special character, as a regular expression, a special character. Also, I would have to escape these curly braces with a slash in order to make it recognizable as extended as a special character, as a meta character. So without extended regular expression, with just an E, I would have to do this, this, which makes this expression very difficult to understand because there are so many slashes. Okay, it still works, but this is much more difficult to understand and to see what is going on than this other one. So that's why in this case, we are using extended regular expressions to make it cleaner, to make the regular expression cleaner. And another point is that usually we say substitute something, and we usually use this this backslash or this slash, whatever it is, to separate the parts of the command. So the pattern and replacement. But in this case, it is better to use some other character, and we are using some other character because this pattern, this slash, is inside the pattern that we are trying to match. So we have this character in the pattern, and if I try to use this slash here, then I would have to escape this one. And also, I would have to escape this one. Okay, let's try with this. And also here. It still works, but this is much more difficult to see what is going on and to understand it. So that's why instead of this separating character, I'm using this one. Now, as I said, it is possible to use more than one regular expression with a command. For example, in this case, we are using two expressions or two commands, two sed commands with the command sed. Sometimes it is better to, or it is possible to include all these commands in a single file, one command per line. And we will see an example with this. First, we will download this example with this command, wget https linux fs examples. Lesson 07. This distros.sed. Let's look at the content of this file, distros.sed. So it has the extension .sed because it is a sed. It contains some sed commands. This is a comment. It starts with a hash, and it is a comment. So this is a sed script to produce a distro report. This is an empty line. Empty lines are ignored. And then here we have the first sed command. This is an address, which is the first line. And this is the command I insert. When we say insert, then we add lines above the matching line here. If we say append, then we add lines below it. In this case, we are inserting above the first line. This is an empty line. We are inserting an empty line, and then we are inserting this line as a title, and also another empty line, because this makes it to continue to the next line. And this is the second command, which is a substitute. And we have just seen this command. It is changing the format of the date from the given format to year, month, date. And actually, I forgot to mention this $sign. This $sign makes the matching at the end of the line. So it is matching these numbers, but only if they are at the end of the line, not in the middle of the line, for example. And the last command is like the command tr, which is replacing lowercase letters with uppercase letters. But different from the command tr, this y does not recognize ranges or character classes. For example, in tr, we can say from A to Z. It is not possible to say it in this command, so we have to list all the letters of the alphabet from A to Z. And also, we can say we can use character classes lower. In TR, it is not possible to use character classes with this command. So, but what this line does is converts all lowercase letters to uppercase letters. Now, let's see how we can use it to the command with sed to modify distros.sed and to modify distros.text and to generate a report. So we use it like this: sed this capital E is again to use extended regular expressions, because we need extended regular expressions for this command here. This -f is read commands from a file. So we are reading the commands from the file distros.sed. And finally, the file that we are going to modify, distros.text. And here is the output. We have an empty line, and then a title, and then another empty line. And these are introduced by the first command of this file. And then all the lowercase letters are replaced with uppercase letters, and also the data for the format of the date is changed as we wanted it. We can save this to a file. Instead of sending it to the screen, we can save it to a file. Okay. Now, let's see a command that can be used for spell checking. Spell checking is finding mistakes in words in written text and replacing it with the correct word. For example, let's say that we have a file like this. So I just created this file that contains only this line. And in this line, there is a mistake here. It is a typo. Some characters are typed wrong or are missing. Now, if I say, if I use the command aspell, command aspell can be used for spelling. There is another command, ispell, like this. ispell. I'm not really sure what are the differences between them, but at this time we are trying this command, aspell, and then the command is check. We are checking this file. We are checking this file food.txt. And now it has detected that this word is mistyped, and it is giving some options to replace it. 1, 2, 3, 5, 1, 2, 3, 4, 5. And it is waiting for some input here. Either the word that I want to replace in this file, or add a board, etc. So there are some other options here as well, or ignore or exit. So I think the right word is the first one. So I'm typing 1, and it immediately replaced it. So it has corrected this word. This command, aspell, can work with HTML files as well. So let's get an example HTML file that has some mistakes in it. wget https linux CLI fs.al, and then examples lesson 07, and then foo.html. So this is an HTML file with tags, and here there is a misspelled word. Now let's see how we can correct it using the command aspell. First of all, let's exit from nano with Control X. Control X, exit. And then aspell check foo.html. Actually, there is a second word that is misspelled, this one here, and the correct option is the first one. So I'm typing 1 here. I'm typing 1, and it is going to the second word that needs to be corrected. And again, the correct replacement is 1. So I'm typing 1 again. and it is done. Okay, this is corrected with double S here, and also this is corrected with U here. Jumped. With the command help, we can check the options that are available to this command. Okay, it has some options, and with Q we exit from less. Now we will start the next lesson with, and the first section is archiving and backup. We will see some commands that are used to archive and compress files. And one of them is gzip. But first of all, let's create a test file. For example, by taking the output of this command. So the output of this command we are saving to the file food.txt. So less food.txt. And now I can compress this file using the command gzip. I think these are old files. Let me delete this one. And these .back files are created by Aspel because it is modifying the original file, but it is also keeping a backup of the. It is modifying the file, but it is keeping as a backup the original file, just in case that we want to revert back the changes. So after compressing, we see that we have this file that we compressed with the extension .gz. GZ, yeah. And if we want to uncompress, we can use gunzip. And now the extension .gz is removed from the file, and we have the file uncompressed. And notice the size. It was 2.6K compressed. It is 13K kilobytes uncompressed. So it is almost 5 times larger uncompressed than when it is compressed. So it has compressed it 5 times or something like this. The command gzip, so we used it like this. We gave a file and it compressed it, but it can also take input from. It can also take the input from standard input. For example, the output of this command through the pipe is being set to the command gzip. and then the output of the command gzip is stored to the file foo.text.gz. So this was the original file. This is the new file that we just created. Yeah. So the command gzip is taking the input from the pipe, from the standard input, and by default it is sending it to the standard output. But we are redirecting it. We are redirecting to the output to a file. And we saw that when we unzip it, let's use this option. So when we did not use any option, it just removes the extension and then creates this file, uncompressed file. But with the option -c, we are sending the output of the command to the standard output, to the screen. Now we have seen the command cut, which can be used to display the content of a text file to the screen. So it is sending the content of this text file to the screen, but it does not work with compressed files because they are kind of binary. However, we can use, there is a command that is called zcut. Zcut will first uncompress it and then display it to the screen. So in order to display a zipped file, we can use the command zcut. And similar to the command zcut, there is also the command zless to show the content of a zipped file page by page. It will uncompress it on the fly and then show it page by page. Now, besides the command gzip, there is another compression program that is called bzip2. bzip2. Now, the files that are compressed with this program get this extension, bz2. And you notice the size of the file, it is 2.4 K, 2.4 kilobytes. It is smaller than 2.6 kilobytes. That was the size of the file compressed by gzip. So this is usually a better compressing program. So it achieves a better compression. And similar to gunzip, we have the command bunzip. We have the command bunzip too. And again, it will remove this extension and it will save the unzipped content to the file foo.text. Now, this gzip and bzip2 are used for compression, for compressing the content of a file. To create an archive, we can use the command tar. So the command tar can be used to create an archive of files and directories. An archive is a single file, so it is like taking all the files and directories and putting it on a single file, inside a single file. This is a very old program, and it means tape archive. This T is for tape. It is from the time that the computer storage was saved in tape files. Young people maybe don't even know what is a tape. But anyway, so it is a very old command since the time of Unix and maybe before Unix. Now, let's see how we can create an archive with this command. But first of all, let's create a test directory. We have seen a similar example before. So I am creating 100 directories under this directory. From dir 001 to dir 100. Now let's create some files inside these directories. I will create them with the command touch, just empty files. And then under each directory, there will be the files (26 files) from file A to file Z. So there are 26 files under this directory, and under the second directory the same, and so on. Now we can use the command tar to create an archive. With the command with the option -c, we create an archive, and we want to archive the directory testdir. We want to archive this directory, and we want to archive it to the file So this is where the archive will be created. So this is the name of the archive, testdir.tar. This is to say that we are creating an archive, and this is the directory that we want to archive. It is possible to have 2 or 3 directories, but let's test it first with just one directory. So we have too many files here, but we see that we also have this testdir.tar that was just created, and it has size 1.4 megabytes. Let's remove some examples that we have used previously. Okay, let's remove them. So this is the archive that we just created. Now we created it like this, but it is possible to merge these two options like this, -cf. And we know that this works in Linux. It is the same thing. But something else, it is possible, because this command tar is very old, it also recognizes it. It can recognize it like this, without a dash in front. So this means create, and this is for the file, and this is the file name where it will be sold. This is the file name where it will be saved, and then the directory. So you may also see it like this sometimes. It works with tar because it is a very old command, and for historical reasons, it is also backwards compatible. So it still works. Now, this command C was to create an archive. The command T is to show the table. Showing the table of an archive means listing the files that are inside the archive. So it is going to show a list of all the files and directories inside an archive. So it contains this directory testdir, and then this directory, and then this file, and so on. So with this option T, we can see the content of an archive. Let's try to add also the option V, which means verbose. Verbose means with more explanations or with more information. And in this case, it shows a long listing of each file. It shows the permissions, ownership, the date of creation, modification, etc. So it was this option verbose that makes the command tar to give more information. And now let's see how to extract this archive that we just created. Let's create another directory. And then we go inside this directory. Then the archive is above. This is the archive. It is in the directory above. And now we can say tar and then -x. This x is for extract. And then -f is again for the name of the archive file. So we are extracting this file. And again, we can join these two options like this, -xf, or we can also say xf. It is fine. And let's see what happens. Now, after running this command, then we get the content of the archive in the current directory. And it is this directory, testdir. So all the files and directories that were inside this archive now are extracted in the current directory. And also, this command is another way to view the structure of directories. So this command, the command tree, this is to preserve the coloring because when we pipe, when we send the output to pipe, usually it does not display the colors. It suppresses the colors, but we are trying to preserve the colors. And then we pipe it to the command less, and then with this option -r, we make it display the colors. Otherwise, it will be something like this. So there are special codes that represent the color blue, for example, and this is what is coming from the output. And the command less is displaying them as plain characters, but with the option -r, it will interpret them correctly as being the colors. So this is the command. by default, the command tar is removing the leading slash from the path of files and directories. So in the previous command, we archived a local directory. So the name of the directory was local. So in this command, we are archiving this local directory, and so the names of the files and directories were relative. But even if we archive an absolute directory, if we give the path of the directory as an absolute path, it will still remove the leading slash from the names of files and directories. So let's try to see this. First of all, I'm removing this directory that we used for testing, and echo print working directory. So this is the absolute path of the directory testdir, and it is being shown here. So it starts with this leading slash, and now we will archive this directory with tar create, and then file. And then this is an absolute path. The path of the directory is an absolute path. This is testdir. Okay, now it has created this archive, and it is warning us removing leading slash from member names. And if we extract this directory to see what is inside it, for example, we create a directory foo again. And then we extract it, tar x, f. And then we use the command tree to see again. Control R, tree. Okay, this command. We use this command to see the content. We see that it has saved the full path of each directory and of each path, but without the leading slash. If it saved it with the root slash, then when we extract it, then it would extract it to the same place then that it was backed up. So we used this directory as a backup to create the archive, and then when we extract this archive, then it will overwrite it on the same place. And very often this is not what we want. We create an archive and then we extract it to some other place, not extract it to the same place, to the same directory. And I guess this is why it removes the leading slash by default. And instead of extracting all the files from an archive, we can extract some of the files, only some of the files. For example, let's list the content of the first archive, this one. tar, we list it with t, and then the file is testdir.tar. And then by default, if I just press enter, this is going to list all the files and directories in the archive. But now I'm typing what it should list. For example, it should list only this file, testdir, and then test dir 001, and then file capital A. So I am giving this a file name, and it is listing only this file name from all the files that are in this archive. So it is just showing this list. And now, instead of listing it, I can use the option -x to extract from the archive. And actually, it is extracting only this file. And let me try with a directory, because so I removed it and created it again, and then I go to the directory foo, and then the command now becomes this, because this archive file is in the directory above. And let's see what we have here. Let me try with 3. So we actually have only one file. It has extracted only one file. So we are saying extract from this archive, but we are saying extract only this file, the file with this name. And we find the name of the file with the command, the name of the file that is to be extracted with the command t, which is listing the files in one directory. For example, if I want to extract some more files, I can use the command above again, and now I'm saying extract the files ABC in the directory dir 002. So it is going to extract only these 3 files. And let's see with the command 3 again what we have. So this was extracted from the first command, and now these files are extracted from this command. So we are extracting files selectively. And it is also possible to extract files using wildcards. So I can say wildcards here. And then any directory, and then file A. So it is going to extract the file A on each directory. And in order to prevent the shell from expanding this star, I'm using single quotes to enclose this wildcard expression. I'm using the enclosing the wildcard expression in single quotes. And let's use the command 3 again to see. So these were the files extracted previously, but now we have all the files named A from each directory, which were extracted with this expression. And sometimes it is useful to combine the command tar with find and gzip. For example, if we want to archive only the files with name A, so I'm removing this because we are done with this example. So if I want to archive all the files named file A in this directory, not all the files, but only these files with this name, what can I do? I can use the find command, first of all, to find these files. Find in directory testdir name file A. So it is going to find all the files with this name in this directory. And we can see that it does this. So, and now instead of piping it to less, I can execute a command, exec, and the command is tar with the option -r, and then the output will be saved to the archive with this name, and then we append also this, because this is a command that is being executed by the command find for each file that it finds. Now this option -r means append. So the command find will find a file that matches this filter, and then we'll execute this command. And this command will append it to this archive. And then it will find another file, and then we'll append it to the archive again, and so on. And so it will create the archive by appending all the files one by one. So I press enter. And now let's see what we have inside this archive. Tar tf. So this is the list of files inside this archive, and so we see that we have all the files that were found by the command find. Now let's say that we want to append all the files with name B, file B, to this archive. I'm executing the same command again, but now the filter is to find these files, and then it will continue to append to this archive and see the content of the archive again. Okay, here are the files that were appended to that archive. Let's see another example. Now So we used this command exec and then executed the command tar, and then we appended to each file to the archive. But we can also pipe the output of the command find to the command tar. But the command should be like this now. First of all, create, and then the file will be, let's say, testdir.tar, and then we have this option -t, and then this dash. Now this option -t tells tar which files to include in the archive. So usually here comes a file that contains the names of the files that should be included to the archive. So each file in one line. But we are not giving a file here, we are giving this dash. And this dash means that read the names of the files from standard input. And standard input is what pipe is sending to the command. So find is finding the names of the files, and through the pipe, they are sent to the command tar. And this is telling the command tar to include these files in the archive, to create an archive with the files with these names or these paths. And here is the name of the archive, but actually we can replace the name of the archive with this minus here. And what this minus means is that instead of saving to a file, send the output to the standard output, to the screen. And what we are doing is we are using another pipe. So the output of the command tar is sent as an input to the command gzip. And now the command gzip will send the output to standard output, and we are redirecting it to testdir.tar.gz. And we can combine these two options, and also it is possible to remove this space here, and also this space can be removed. It makes it look nicer, and it is easier to remember in case you have to remember it. But let's try it. And here is the file that we have created. So in this case, we are combining the output of the commands find and tar and gzip to create a compressed archive. But actually, the command gzip, the command tar has an option z, which does this. It creates a compressed archive, and the option z means compress it with the program gzip. So instead of doing this, we can write it like this. Or actually, it can also be the extension tgz. So we have created this archive. So it is not necessary to send the output of command tar to gzip in order to compress it, because we can use this option z, which does the same thing. And then the extension for a compressed archive can either be .tar.gz or .tgz. Just another minute, and then we are finishing for today. Now, similar to this option Z, we can use this option J. And in this case, the command tar, we use the compression bz2. And I'm not sure. No. So it is again a compressed archive, but it is compressed with bzip2, which we have seen before that it is doing a better job of compressing files than gzip. So this is the file that we just created, and we see that it has this size, 512 bytes, but the file that is compressed with gzip has this size, 893. So again, this bzip2 has done a better job at compressing files. So let's stop here for